Hey, welcome back, continuing your journey of trigonometry, and we're going to move now into areas where you can see a little bit more of an application to everyday life. So let's get on board and see where this goes. And the first one that we want to do are angles of elevation and depression. And you can see the definition there. How much do you have to raise your eyes to see an object in the sky, maybe a plane or something? And therefore, could you estimate its height and its distance away and all that sort of thing? Very important ideas in navigation, which I think is the next section along from this one. We're just going to get ready now to use the words angle of elevation, meaning the angle that you raise your eyes from the horizontal to see a plane or something like that. So we're going to start to work with angles again in triangles and working out distances. So let's come down and have a look at the other one. If you're flying in the plane and you look straight ahead, what angle do you have to depress your eyes or look down from the horizontal to see something? It's called the angle of depression. So this is sighting objects in the sky or looking down from objects in the sky and estimating distances, heights above the ground and so on. So elevation, to elevate, means to go up, so look up. To depress, looks down. Depress, if you're depressed, you're a bit down. So here, looking down. So they are the words we use in maths to indicate those things. Can you notice here, Pearson's, and again I've used screen clippings here from Pearson's textbook, and we're good to have the e-book or hard copy handy by so you can follow through there. Can you see what they're making? A very important point here. Usually, if you're looking down from an object, that angle will not actually directly be in a right angle triangle. You might make a vertical line down to the earth and then a point that you've been looking at along there, but that this angle that you initially measure, your line of sight angle, depressed down, won't form part of won't be in a triangle. But can you see that y and x are alternate angles? So it is easy to actually create a triangle, a right angle triangle with your angle of depression in it, because it's always the alternate angle in there. So again, with this practical work, a big emphasis initially is on let's get a diagram so that we can use SOHCAHTOA and so on. All right, we'll come down. Let's have a look at some worked examples from Pearson's. Some not so much practical ones here, just to give you a little bit of an idea of how we could use it. So here, a marker buoy. That's out at sea, floating, used to guide ships, is 1.3 kilometres away from the base of a cliff. So when they see this buoy, the ship knows, this floating marker, the ship knows that there is danger somewhere. In this case, it's to warn them that there's a cliff coming up. To the nearest degree, was the angle of elevation from the buoy to the top of the cliff? Answer the correct to the nearest degree. So when they are at the buoy, what angle do they have to raise their eyes there, coming and looking at this diagram, to see the top of the cliff? So this diagram is very, very important. The diagram is crucial to our problem solving here as we go into these practical, interesting problems. So first of all, as before, go to the angle, look out, that is the opposite, see it's labelled there. Go to the 90, look out, so that will be the hypotenuse, and the side that's left is the adjacent. So I've got them all listed there. Now list down the information. Don't know theta, do know the opposite, do know the adjacent. So I'll put it here into SOHCAHTOA. So that will help us work out which ratio we're using. So it's opposite over adjacent there. So it's a tan is opposite over adjacent. Putting in the numbers carefully. So this protocol, the thinking down here, is extremely important that you use a very structured and analytical approach in this problem solving now. So we now have that this missing angle has a characteristic ratio or unique ratio of 120 over 1300. So we're going to go and search for that. So that's the inverse tan. That means the angle whose tangent is this given quantity. So it's inverse tan. Right, come down here a little bit so I see this little bit down the bottom. Use the calculator. You can do all that in brackets. Don't need to have to work out any parts separately. So remember tan now. You've got the little sine, cos, tan set on your calculator. And you want the tan neg 1 because you have the ratio and you're coming back to find the angle. So it's a shift, the yellow button, hit tan, and you get that inverse function. And if you do that, you get this angle here, and to the nearest degree, it's 5 degrees. Please remember, state your answer. State your answer in the context of the problem. No good saying theta is 5. You've introduced theta as your mathematical symbol to represent the thing they asked you to find. What did they ask? The angle of elevation from the buoy to the top of the cliff. So you do that in those words. The angle of elevation from the buoy to the top of the cliff is approximately 5 degrees. Gives you an idea of the people on the ship, how much they have to look up from the buoy's distance to see the top of the cliff and look for the lighthouse or whatever other warning sign might be up there to stop the ships running into the cliff. Okay, let's do another one. Then we've got another one down here, worked example 12 here. And this one is arranged at the top of a lookout tower. Now, this is an important idea. Spots a small fire at an angle of depression of 12.5. He knows the tower is 76 metres high. Can he work out how far away the fire is? Okay, so he's up the top of a tower, so let's draw the tower, 76 metres. Now he's looking down, so that's 12.5, to the ground over here at the fire, F for fire maybe. Now we know, therefore, that this angle would also be 12.5 because between that line is parallel to the ground, we have a pair of alternate angles. Do you remember that between two parallel lines we have some properties connecting angles? These two are alternate and equal, and these two are alternate and equal between parallel lines. So we can use that. So what we've got now, go to the angle, look out, so that's the opposite. Go to the hypotenuse, look out, that's the hypotenuse. So the other one is the adjacent, and that's what we want to know now, how far the fire is away from the base of the cliff. So let's list the information. We know theta is 12.5, the opposite is 76, the adjacent is the x that we're trying to follow, we're trying to find. So put down Sokotoa now. The book's leaving this out a little bit here. So what do we get? What have we got? We've got the opposite and the adjacent, those two. So the tan of 12.5 is the opposite over x. We've divided by x here. So we want to now multiply by x. We get that line, and then x has been times by tan 12.5. To get x back again, we will divide, and so we come up with this answer here. All right, so to the nearest metre we have 343 metres, so it's not very far away, that fire. So we would make our answer here, not in x land. X has been introduced by mathematicians like yourself to solve problems. Here you're using it to replace the distance, so we state the fire is approximately 343 metres from the base of the tower. Are you ready? Can you see there's some exciting possibilities in the practical sense here, in the real world sense? Let's go down and have a look at Pearson's exercises here, and as you can see down the right, I've now tried to put the solutions next to the answers, sorry, these are not the fully worked solutions. I think you have to get those from the ebook if you want to see all the steps. And the most important thing, the number one thing here, is a good diagram. A diagram. So, as I've said before, it's important to just chew off enough to digest. Don't try and read the whole problem. Let's just try to build the diagram as you go. Okay. So you need to have a look at those, here they are here, worked examples from before. And of course you can toggle back, keep the video running, pull it back and have a look at those worked examples again. Okay, so we've got lots of interesting ones here. Let's look at this one down here, this is an interesting one. A traffic signal 3.95 metres high casts a shadow across the road. The angle of elevation of the sun is 24.8. Find the length of the shadow. Correct to 2 decimal places. So you need to actually have a look there at the angles and draw a diagram, and you can actually estimate the length of the shadow. Helicopter in the next one, that's an interesting one. So I'll just bring it down here. So leave it on those perhaps first 6 there, and you can have a go. Mark your work as you go and check. Go back and look at the work examples, because this is of really practical importance. Have a look at this helicopter one, that's interesting. A pilot can see another helicopter, and that's going to be important to work out how far that helicopter is away from your own. Don't want to run into it, mate. Okay, so pause presentation, have a go. I'll carry on down here now. We'll go into the understanding one. So here's question 7. I think question 7's answer was back up there, so I'll just leave it there. We'll have a go at 7. Easy to pause it then. And the understanding question is getting slightly harder, understanding and reasoning. So we go down to question 12 there. You might not have time to do all of them. I want you to pick a couple out. And of course, the key thing again, I want to write over here, I'll write it bigger this time, is you need to have a good diagram. So when you're reading the question, just bite off just enough that you can draw pieces at a time. If you try to read the whole thing, it could get more difficult. Just take the small pieces, like a yacht is 1.8 kilometres away from the base of a cliff, so you can draw the cliff and then the distance, right, that sort of thing, and start to label it 1800 metres or 1.8 kilometres. Let's keep the units the same, that sort of thing. So just gradually build up your diagram. Okay, so you could pause it there. The answers are up here to this next step of understanding and reasoning. All right, so what I want to do now is leave you with these 2 open-ended questions. And as usual, of course, the open-ended means you have some choices as to what numbers to use in the context of the question, and you can draw different diagrams for different scenarios. So I will leave you to have a go at that. These are the sorts of questions that you need to check back with your teacher on, because they are open-ended, a bit more reasoning, a bit more thinking required. All right, I hope you're getting excited. In the next presentation, there's a couple more to go. In the next presentation, we're going to look at even a more important application of trigonometry to navigation and bearings and things like that. So do your work here, get some good solid skills ready to build to some more applications. And I'll catch you in the next presentation. For the moment though, it's cheers from me.